You guys can sit there in silence. All right. Find the derivative of f of x equals 4 over x at x equals -3. This is a different way of asking this. They're not telling you what the actual point, what the coordinates of the point are, but if you put a -3 here, we're talking about the point 3 comma -4/3, or -3 comma -4/3. So that's the point. Whether they give you the x value or the point, that's kind of unnecessary, I guess. So we have f of x. In every single problem, we've had to figure out what is f of x plus h. All we do is, instead of the x going here, we put an x plus h there. Do I need the parentheses around x plus h? I guess for the sake of consistency, I could put them there, but that denominator is not being multiplied by anything or subtracted or anything like that, so technically not necessary, right? But for the sake of consistency, I've been saying have the parentheses around x plus h, we'll put them there. So the limit definition of the derivative, I'll write it for the umpteenth time. The limit as h approaches 0 of f of x plus h minus f of x all over h. So we have this. So fill in what we know. The limit as h approaches 0 of 4 over x plus h minus 4 over x all over h. I got rid of the parentheses this time. I'll just keep it. And I've also gotten in the habit of putting f of x in parentheses too, right? It's just good policy to keep those parentheses around x plus h, but also around the entire function f of x. Hopefully at this point you realize when you need them and when you don't, okay? But it's like a life vest, right? What do we say about the life vest? It's better to have it and not need it than to need it and not have it, right? If you're on a boat and you see the life vest and you're like, why do I need that? Should I trust the captain of this ship? Oh my gosh, he puts life vests on his boat, which save people from drowning. I'm kind of nervous, but at least it's there just in case, rather than getting on a boat that has no life vest and then the captain, sets you adrift and then the pirates come and then they take your boat and you have no life vest, right? It's better to have it and not need it than need it and not have it, right? It's parentheses, just like parentheses. Hopefully you're never on a boat that gets overtaken by pirates. I guess that's what I'm saying. Okay, so here we go. Little bit of humor. I'm sorry for ruining your humorless approach to learning. I really apologize. Yes. It's a shame on me. All right, so what do? We simplify, right? We're supposed to. Now, in the past, the problems that we've done have all been about expanding, right? We're going to expand to this quadratic, and then we're going to simplify it back down. There's nothing really to expand in this function the way that this one's written. But simplifying can occur. I can take this numerator, which is very cumbersome looking, very awkward, that includes two fractions, and I can simplify that numerator. So I think we should do that. Let's go off to the side, and I'm going to write small here. So I'm going to do this over here. This is like margin work, right? So I'm going to take this stuff in red off to the side. I'm going to simplify it. Then I'm going to bring it back into the limit with the h underneath. So if I want to combine these and simplify it, what do I need? Common denominator. So I have to multiply this x right here times the 4 and the x plus h. And then I'd also have to multiply this by x plus h on the top and bottom. Right? So I'm finding a common denominator by multiplying the denominators of the different fractions. So we end up with 4x over x times x plus h minus, we can do this, 4x plus 4h. we very rarely want to multiply the denominators together, but we almost always want to multiply what's in the numerators, meaning we don't want to FOIL what we see down here, but we almost always want to FOIL what we have on the top. Okay? That has happened multiple times. You think back to the trig proofs that we were doing, the trig identity stuff earlier in the semester. Now when I combine these, I'm taking 4x minus, there's two terms up here that I'm subtracting. So I have to remember to subtract both of those terms, and that's all over this denominator. And the 4x's that are up here are going to cancel. So I'm left with negative 4h over x times x plus h. And this fraction is going to go back in here. So now, ow! Sorry. I ran into the corner of this chalk ledge. I'm glad. You know what? You know what? I get hurt, you guys laugh. I tell jokes, you stay there and you do nothing. Damn you people. Seriously. Never mind. Whatever. So the limit as h approaches 0 of negative 4h over x times x plus h all over h. Right? I still had this and this that was that I didn't touch when I simplified the numerator, but it's coming back in now. So here it is. Here's the h that was the fraction and the h that was with the original fraction. So now, if I want to simplify this, I still can't put the 0 here. That's still a problem. But if I want to simplify this, I can take this h that's in the bottom and I can bring it to the top. Right? That's one of these fraction simplification steps we've had many, many times this semester. If you have a fraction that includes a fraction in the numerator, you can swing the denominator into the top. So now we have the limit, SmartBoard's not cooperating anymore, of negative 4h over the h from the bottom comes up, it joins the x and the x plus h. And my denominator is a sequence of multiplication. The h is being multiplied by the x being multiplied by this binomial. So the h that's on the top can cancel with the h that's on the bottom. And we have the limit as h approaches 0 of negative 4 over x times x plus h. That's a negative 4. SmartBoard is being silly. There we go. Now we evaluate. When the 0 comes in, to here, that binomial becomes just an x. So we have negative 4 over x times x, which is negative 4 over x squared. So there's our derivative. We've simplified the difference quotient. We've evaluated the limit as h approaches 0 for it. And the question was, when x equals negative 3, therefore, at x equals negative 3, the slope is negative 4/9. We plug the negative 3 in for x. We square it. Negative 3 squared is 9. Negative 4/9.